Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. So today we have a pretty interesting video and problem I'm very excited about, so let's get into it real quick. All right, so the problem's called Kth Smallest Element in a BST, right? It says, given the root of a boundary search tree and integer k, right, return the Kth smallest element in the tree, right? So pretty much what they're asking us, guys, is to find, right, so they're going to give us this binary search tree, right? And then our job, right, is to find the Kth smallest element, right, in the tree, right? All right, so for this example, right, when k is equal to 1, right, it pretty much means that, you know, the smallest element, right? If k is equal to 2, right, that means that's the second smallest element, right? You know what I'm saying? So that's what this stands for, so that's good. Yeah, so k is equal to 1, so we go to 1, right? So now that's good. All right, so we go to this one, right? This one's interesting. K is equal to 3, right? Pretty much means that there's the third smallest element in the tree, right? And yeah, guys, so so 1, right? So the smallest element in this binary search tree, pretty much 1, right? That's where we return 1, right? That's the smallest element in the tree, right? And then this one interesting as well, right? K 3, right? The third smallest element, right? Third smallest element in the tree is 3, indeed, right? Because 3 is the smallest element, right? If you look at all the numbers, right? I'm saying. So we've done some problem that kind of sounds similar, right? You know, the Kth largest element in an array, right? We did that problem, and we kind of use a heap, right, to solve it, right? Yeah, we could probably do the same for this problem, right? Add everything to a heap, right? As we traverse the nodes, right, and only storing the Kth smallest elements, right, in the max heap, right? I could easily solve that by doing that, right? But it wouldn't be the most optimal solution. I'm saying we could. So this one is a binary search tree, right? It's not an array, right? It's a binary search tree, right? We're giving reference to the root, right? We could easily find it, right? It's not a binary tree, right? It's a binary search tree. You know what I'm saying? So that pretty much tells you the elements are already organized for us, right? I'm saying so we could easily do an in-order traversal of the tree, guys. You know what I'm saying. As we visit the nodes, right, we're gonna have this property, right, that this variable that we're gonna pretty much decrement every time we visit a node, right? And once we get to k is equal to 0, right? I mean, let's say, you know, the variable equals to 0, right? That's when we know we've reached the Kth smallest, right? You know what I'm saying? Kth smallest node, right? Because that's the Kth node we've seen by doing the in-order traversal of the tree. You know what I'm saying? So look at it. If we did in-order traversal of this tree, right? We go boom, boom, boom. So in-order traversal is on left root, and then you visit the right side, right? So the same thing. So we go to 1, we boom, null, right? And then we go back up, right? 1, right? And then 1 is the smallest, right? So that's where k is equal to 0 after we decrement this variable, right? And then bam, we return 1, right? Same thing for this one, right? We visit the left side first, right? Boom, 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 return back. All right, k is equal to 2, right? And then we go back up, k is equal to 1, we go back up, k is equal to 0, and then we return that node as the smallest element that we've seen, right? So just like that, guys, no solve it. So let's go ahead with the implementation. All right, so the code should be relatively straightforward, guys. So pretty much, guys, we're gonna have some instance variables, right? So pretty much it's properties of the class, right? So so pretty much what we're gonna need, right? We're gonna need the actual number, right? Pretty much just call it smallest, k smallest, right? Let's call it that. All right. And then we're gonna have this this variable that's gonna pretty much helping us in keeping track of the k smallest, right? The k node, the pretty much a k, right? So int k, right? Okay. And then yeah, so there's that k, right? Gets initialized with the k that's passed in, right? This one, right? So we have access to that, right? And then after that, right, the next step will be to pretty much do k smallest is equal to 0, right? And then now the next thing that we're gonna do, pretty much, you know, do the in-order traversal, like I said, in-order. We're gonna pass in the root, right? Because that's all we need. And then after we're done, we're simply gonna return k smallest, right? All right. So yeah, guys. So So yeah, now we're gonna be implementing the logic, right? The in-order traversal, right? So pretty easy in-order traversals, guys. What I'm saying, this is the power of of that, right? So pretty much we tree nodes, root, right? So we got our base case. If the root, right, equals to null, we return, right? And then yeah, and then we do in order, right? So we visit the left side first, right? All right. And then we know we're gonna be visiting the right as well, right? Right. And then in the middle, right, the roots, right? So now we need to do some things right now, some processing, right? So first things first, right? As we visit the nodes, guys, I told you guys we're gonna be decrementing the k, right? And then once we get to k is equal to 0, right? Because remember we initialize k with the k that's passed in, right? So k is equal to 1. This k is equal to 1 as well, right? So once k is equal to 0, right? We found the thing that we're looking for, right? So pretty much we do the k smallest, right, is equal to root that val, right? And then we simply just return after that, right? Yeah, so I think we're in pretty good shape. Let's check if we pass the small test case. All right, cool. Let's say we pass all the test cases, guys. Perfect, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch the video, and I'll see you guys in the next one.